Hello and welcome to this lecture on integral calculus. In this video, we are going to see a problem under the title Area as a double integral using polar coordinates. So, under the polar coordinates, we used to study a new shape that we call it as cardioid. It is a heart-shaped curve that appears in the polar coordinates. Here, I have listed four equations for the cardioids of facing some other directions. If it is of a into 1 plus cos theta, it will be right facing cardioid. If it is a 1 minus cos theta, left facing cardioid. 1 plus sin theta, upward. Minus, it will be downward. Okay. So with this general case, I am giving you a picture. There it will be a into 1 plus cos theta. Sometimes it may be a different number that multiplied with the cos function and sin function. So in more general case, a plus b cos theta will be like this. Here the curve will have 2a as same. It will be of 2a. So a plus cos theta it will be on rightwards, minus cos theta leftwards, and plus sin theta upward, minus sin theta it will be downward. If I'm making this first term to 0, a equal to 0, then I'm getting a graph as a circle. If it is a greater than 0, the a will be always positive. So if it is of positive curve, a cos theta, it will be on the rightward. Minus c a less than 0 means minus a cos theta. It will lie leftwards. As same, greater than 0, it will be on the upward. Less than 0, it will be on the downward. Okay. So then we go for a problem. So they ask us to find the area enclosed by the cardioid. So simply they have given r equal to a into 1 plus cos theta. So here they have not given any of double integral evaluation with respect to the variable r and theta. So now we want to decide it. So if they are asking for any of the area under the polar form, then this will be the only one option. Okay. So here we are going to do the same thing, but we need a region. So this will be the area, but we need the region capital R. So how do we decide for the region? So simply this will be the graph because they have given that R equal to 1 plus A into 1 plus cos theta. So this will open on the rightwards. So here it will be of 2A. If it is A, here it will be 2A. So here just see the x-axis equally splits the area of the cardioid. So if I am finding the area above the x-axis will be equal to the area under the x-axis. So instead of finding the area for both the sections, it is enough to find the area for the above curve, above region alone. Okay, so since we know that, how do we find the limit r? R is the R starts from the inner radius and ends to the outer curve. So this will be the R. So outer curve will be of R equal to 1 plus cos theta. So it starts with the radius center radius then lower limit will be 0 and then upper limit will be a into 1 plus cos theta. Okay, so now then we have to decide the limit for theta. So since these upper region, now we are going to find the area for upper region alone. So the upper region varies from 0, the totally the cardioid varies from 0 to 2 pi. If you take the upper region alone, it takes the value from 0 to pi. So it lies on the two quadrants. So theta will be on 0 to pi. Okay, so now we find the limits. Then we go for the problem. As I told you that r will take the limit as 0 to pi and theta will take the value as a 0 to a into 1 plus cos theta. Okay, so now we have to evaluate this part. So since r integration of, we will evaluate the inner integral dr d theta. So it will be of r square by 2. So we have to substitute the limits. So it will be of a into 1 plus cos theta, a into 1 plus cos theta. Okay, so on the next step you will get r square by 2 a into 1 plus cos theta. Then we will substitute the limits instead of r square. 2 get cancelled. Instead of r square, you will substitute the limits a into 1 plus cos theta. Then it makes a square. A square is separately and 1 plus cos square cos theta whole square. So we have studied about the formula a plus b whole square. While doing before the integration, we know that the formula cos square theta can be written as 1 plus cos 2 theta by 2. Since we can simplify the term 3 by 2. 3 by 2 comes from here, it is of 1, and if I split the term it will be of 1 by 2 plus by 2. So simply we will get the value as 1 by 2 cos 2 theta and 2 cos theta. So here we have to evaluate this with respect to theta. It can be done that a square integral 0 to pi d theta plus 2 into integral 0 to pi cos theta d theta plus 1 by 2 integral 0 to pi cos 2 theta dt. Then integration of d theta with respect to theta, then I will get 3 by 2 theta. So then here integration of cos will be sine, integration of sine 2 theta will be cos 2 theta. Then already we know that sine n pi is always 0. By using this format, while substituting to the value sine 0 is 0, sine pi n pi is 0, sine pi is also 0. So with this, finally we get the value a square into 3 by 2 pi, because this becomes 0, this also both become 0. So only the value of pi. So here it is a square into 3 by 2 m, and we may make a multiplication over the term. Finally we get 3 by 2 pi s. Then we go for the next problem. Finding the area between the two curves r equal to 2 cos theta, r equal to 4 cos theta. So simply the region of integration will lie from minus pi by 2 plus pi by 2. You can check the value because here we want to find the area between, we want to evaluate this, we want to find the area between the two curves r equal to 2 cos theta. So here it will be of 2, here it will be of 4. So the diameter of each circle will take the value of a. So here the value of a equal to 2, na, that will be a small circle with the diameter 2, and a r equal to 4, 4 cos theta, na, there will be a circle which has diameter 4. And also if you choose the value of r equal to 0, if I choose theta equal to 0, you will get r equal to 2, and theta equal to pi by 2, na, you will get r equal to 0. If theta equal to pi, then you will get r equal to minus 2. So here it is 2, you are getting 0, and minus 2 is not possible because the graph lies only on the first quadrant, so it is not possible. So here we want to calculate the whole area. So here if I choose this theta to 2, na, it is from this curve to this. Okay, so since we have a remaining part, so of course here it ends with 0 to pi by 2. Now there should be a remaining part again up to minus 3 by 2 minus pi by 2, which is also giving the value as 0. Okay, so here the same, what you will do, we will find the value of r. So I will draw a strip from the center. Here the r value is from 2 cos theta to 4 cos theta, because the two curves are attached to the two ends of the strip, and then pi by 2 is possible and minus it is not possible. Therefore r can take the value from r 2 cos theta to 4 cos theta, then theta can take the value from minus pi by 2 plus pi by 2. So with this we may substitute the limits for the given evaluation, and we may proceed with the problem. So here it is of r dr, we can evaluate as r square by 2, then apply the limits, and if I'm squaring off, it will be 16 cos square theta minus 4 cos square theta. Then we can make a subtraction between the two terms. You will get 14 minus 4, it will be 12. So 12. So we may take the 12 outside the integral. Then it becomes 6 into cos square theta. Of course, already we have studied about the formula. Cos square theta can be written as 1 plus cos 2 theta by 2. So again, we want to integrate the given expression with respect to the variable x. So in this, while substituting cos square equal to 1 plus cos 2 theta, so we will get the value as 1 plus cos 2 theta by 2. Then if I make a substitution over the limits, you will get pi by 4, and at last the answer will be pi by 2. So here with this integral part, we are finding, we will finding the whole area. So it will be multiplied with the 6 here. So final answer will be 3 pi.